This is a beautiful use case of sentiment analysis that I will show you. So the objective now is I'll show you one case study, and then based on that, I will ask you to solve an exercise. That's the general pattern that we have followed. We did one exercise and ask you to solve an exercise so that we get some good practice. So Yelp is like a website where people can book different types of home services. So Yelp is where people can book different types of home services. You can basically book a plumber, you can book a carpenter, you can book. Okay, so that is what Yelp actually is. So Yelp is like a, a site where you can book different types of home services. Okay, so you can go to a restaurant, you can book a plumber, you can book a carpenter, and you can, after you complete the service, you can give a review, you can give a rating, and then you know that's the whole idea of the data set. So my data set looks somewhat like this. This is the real data set that we are seeing. Yelp.com, you can go to and check. Okay, this is the real data set. Every row corresponds to a review, and we have the different features of the review. Again, when you're running the code, remember, don't use G Drive, because G Drive is where I'm trying to take my data from Google. Yeah, I've already told you how to do this. You can download that file. You can download the CSV file, which I've already shared, and you can upload it separately on Collab. If you want to connect through Google, you can do that also, but you need to make sure that your file is there in the Google Drive location. Now, every row corresponds to a review. We have the business, whom you have reviewed, the date when you have reviewed, how much stars you have given. This is like a feedback, 1 to 5 star. Okay, so 1 star, 2 star, 3 star, 4 star, 5 star. So the rating is the stars that you've given. Text is what you wrote in the review, what you actually wrote. What is it that you wrote? How did you like the food? How did you like the restaurant? And user ID is the user who wrote the review. This is the unique identity column, right? So our focus is we will look at the text and we will predict the stars. This is what we are trying to do. You can ignore all the other columns. This is not important. This is not important. So the big picture understanding. So the big picture understanding that we have here is we are looking at the text, which is X. And based on that, we are trying to predict the stars, which is Y. That is the objective of this particular exercise. Okay, we are looking at the text, which is X. So based on the X, we are trying to predict the Y. Okay, so based on the X, we are trying to predict the Y. That is the problem that we are solving. So based on the input X, the text X, the input, we are trying to predict what is the stars, which is the Y. So you have the historical data, you have lots of reviews that customers have already given. You study that. That is part of the supervised learning approach that we are following. You study the already labeled data that customers have already given, right? This is the reviews that customers have already given. So you please study that labeled data that's already available, right? So you please study that. So whatever data we have, let's study that. Let's study the already available label data that we already have here. And on the basis of that label data, let's understand the patterns. Let's understand what are the patterns that are typically playing out. Study the pattern, build a machine learning model. And on the basis of that, next time we have a new review, we will try to predict what the stars will be. So this is the typical sentiment analysis use case that we have. From the existing data, you study the patterns, you try to draw the association, input-output combination, you draw the association that whenever the text is like this, the user is positive, and whenever the text is like this, user is negative. So you try to draw that kind of an association, and next time you go to some site and the user writes something, or you go to Facebook doesn't have a rating system, right? So you take the data from somewhere where there is a rating system. Somebody will write the review and they will also rate you. So they will explicitly tell you how they are feeling. Are they feeling positive? Are they feeling negative? So they'll explicitly give a rating. So you take the data from that kind of a site and you build a machine learning model. And next time you can look at a platform where users are just writing text, right? Or let's say in the chat here, some of you are typing something. Let's say I'm asking you for feedback and you type something on chat. So you're not giving a rating, but you're just typing something. So I can use that model that I built, and I can predict your sentiment. So next time I have a new text, I can predict what the sentiment is. Or let's say in Twitter, some user, some politician writes some post. Okay, so the sentiment analysis model will be used to determine the kind of comments that people are making, and based on that, how are people feeling? Okay, how are people feeling? There are a lot of geopolitical events that happened in the course of the last 1 month, and let's say some local leader posts something about, some country or whatever, right? Not naming any country, but then a lot of people would have commented, and based on that, the local leaders will get an understanding. Hey, how is my vote base feeling? Because you're a leader in a constituency, right? And you have to keep your people happy. So you put out a post, you put out a tweet, you put out a Twitter tweet or a Facebook post, and based on that, hundreds of people comment, and each of those comments, and nobody is rating it, right? But based on the comment, the model will predict what is the sentiment. Are people positive? Are people negative? Did people like what you say? Did people not like what you say? Okay, so and then these are very, very good, time-tested strategies that a lot of political parties are using today as we speak. Okay, election campaigns and all, what to say. In a big campaign rally that happens, there's a tremendous amount of NLP that happens. A lot of natural language processing is happening. A lot of sentiment analysis is happening to identify what kind of words to use, what kind of topics to speak on, what do people like. Okay, when you go to a constituency, when you go to a city and you talk about something, you should talk on something that people like to hear, that people are positive about. When the prime minister goes to some place before the campaign, now obviously the elections are over, but a lot of back end groundwork would have happened. It is not that they will go and create a random script and start talking about it. You will not go to a village and talk about US policy, foreign policy. Like nobody will understand foreign policy there. They are concerned about basic things. So you should know what people like. And before the script is prepared, a lot of these time tested strategies will be followed, where somebody will put out a post. Somebody, lot of the local leaders will put out posts. They will try to collect user feedback. They will try to collect feedback from their voters. Okay, how are you feeling about this? How are you feeling about this? And this is pure play sentiment analysis that will happen. And then they will collate all that information, and then the final script will be prepared for the leader of the party. Okay, and there are companies doing this work actually. There's a lot of companies which are doing this work. Okay, and if you look at an example, okay, so this is I'm just trying to give an example in the Indian context. Okay, this is a this is in the Indian context. Okay, but you can also look at you know it's in the other context as well. This is a company called IPAC, which is very, very instrumental in the state elections in our country, in India, right? So uh, IPAC came to prominence. This is a company founded by a person named Prashant Kishore. You might have heard of it. Very, very popular figure in political circles and also media. He used to come in a lot of debates before. Now I think that he has his own party, so it's calmed down a little. But uh, it came to prominence in 2014 when they were instrumental behind the uh, massive mandate that BJP won. Okay, and we had our prime minister. Okay, so and after that, in all the state elections, after that, ever since. So if you see IPAC uh, perform phenomenally in all the state elections. So they have state units where they set up different, they set up the state units, and in each of the elections they campaign, and they use a lot of data science actually. A lot of data science they use, and this is you can actually see, very interesting the kind of work they do. Okay, and I feel the best way to learn about a company is to learn about their work, right? So if you look at data analytics technology, you can see what kind of work they do. Okay, I think they have not explicitly listed out, but you get the idea. You get the idea at a very high level, the kind of work that is involved. There's a lot of research analytics work. There's a lot of work that is available on if you see our work. So okay, I think not this one. So if you take a look at it, there's a lot of work that uh, they'll be doing on analytics. A lot of NLP related work will be there, right? So all of these kinds of roles will be available. Okay, yeah. Now moving on, we have the X, we have the Y, and what I'm doing again is A principle I've already talked about. We are trying to only consider two categories. Because the ratings and the stars, there are total 5 different categories of stars, right? If you see how many different categories of stars do we have? We have 5 different categories of stars, right? We have 1 star, 2 star, 3 star, 4 star, 5 star. So broadly speaking, we have 5 different categories of stars, right? Broadly speaking, we have 5 different categories of stars. So we don't need all the 5 different star categories, right? We do not need it. We don't need to identify between a rating 1 and rating 2 because both are bad, right? We don't need to identify between, or we don't need to explicitly separate between rating 4 and rating 5 because both are good, right? So rating 4 is also good, rating 5 is also good. So no need to segregate between 4 and 5. Both are good. So the objective here is to group all the different stars into two broad categories, either good or bad. Is it positive? Is it negative? So we would have done some pre-processing here, and we are saying, hey, if the stars are 1, 2, or 3, if it is 1 or 2 or 3, we will call it bad. If it is 4 or 5, we will call it good. So we are taking all the different star values, unique star values, and we are grouping it into two broad categories. If it is 1 or 2 or 3, we will call it bad. If it is 4 or 5, we will call it good. 1 or 2 or 3 bad, 4 or 5 good. So we have two different classes, binary classification. And why are we doing that? Remember, I told you that this will ensure that you are able to build a good quality model, a more accurate model. Okay, so you will be able to generally build a more accurate model if you do it this way. So the model will be more accurate because otherwise what will happen is uh, there might be a lot of these kinds of errors or false positive errors that you might get. You might have a lot of cases where model predicted 4 star but actually 5 star. We don't want those kinds of mistakes to happen. We don't want a scenario where model predicted 1 star but actually it's 2 star. See, both are bad, right? You actually did the prediction right, but just because you're having more number of classes, you need to be exact. You need to be absolutely accurate in your analysis, but that is not needed. The exact accuracy is not needed. Anyways, so now we move on. Let's see the process. We do tokenization. So we use something called CountVectorizer to perform the tokenization. This is the step-by-step approach we are following, and CountVectorizer is again part of sklearn feature selection, feature extraction. You can see all of these are part of sklearn. Sklearn is the machine learning library in Python, so we are using CountVectorizer. There are other ways to do it, TF-IDF. There are multiple ways to do it. I'm focusing on the fundamental ones to give an idea to all of you. So the stop words equal to English, we will ignore all the English stop words and lowercase equal to true. That means if we have two different words, let's say you've got the word CAT in uppercase and the word CAT in lowercase, what it will do is it will convert everything to lowercase. Because there is no point in having the same word coming in two different cases, right? Otherwise, in the DTM, two separate instances of the word will be created. That's not needed, right? We do not need to create two separate instances of the word. So what it will do is it will go and it will convert everything to lowercase. It will convert everything to lowercase, and it will effectively, create a DTM by converting everything to lowercase. That is the core idea. That is what it will do behind the scenes. It will convert everything to lowercase. Okay, vect.fit and get feature names. You can find out the list of unique features, and there are 25,496 unique features we are having, or 25,496 unique words we are having. This is the real data set. Okay, we have taken a real data set from Yelp, anonymized, obviously. It's we have taken some open source data, and when we go through all the reviews that people have posted, when we go through the entire data set of all the reviews, we can see there are total 25,496 unique terms. Okay, these are the kind of features that people have used. You can see already start to see that so much of data cleaning is required. Because when people write real reviews, they're writing all sorts of stuff. And as I told you, lots of special characters, dot, 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 lots of numbers. Some people would have shared mobile number. Some people would have shared address. Like somebody would have said, hey, I hated the food. It was horrible. Food was very bad. Here goes my mobile number, 77799. Please have your manager, John, call me. I'm very frustrated. I live in this place. All that is not important, right? Where you live, what is your mobile number, what's your birthday. You say, hey, I know I came for my birthday. My birthday was 20th January and I hated the food. Okay, hating the food is one thing. You can mention something about that. But you say my birthday is 20th January. That has nothing to do with the sentiment, right? So, but when the DTM will be created, your birthday 20th Jan will somehow be a column. So all that is useless. you can already start to see that out of those 25,496 features, many of the features are useless. Many of the words are redundant actually. Like Z, 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 Z. Somebody would have written Z 5 times. You will see all these kinds of things happen. Anyways, this is how the DTM will look like in practice. So when you use CountVectorizer, you will end up getting something like this. Okay, you will have all your documents or all your reviews along the rows, and you will have the unique words along the columns. Okay, you will have all your documents or all your reviews along the rows, and you will have all the unique words that will be listed along the column. So that is how the DTM broadly will look like. Okay. Now we can complete this in a pipeline. What we can do is we can use a pipeline, and in a pipeline we can use CountVectorizer and multinomial naive Bayes. Remember, naive Bayes is a classification algorithm. It doesn't have to be naive Bayes. You can use any classification algorithm. The Python will not complain. The code will still work. But generally for text data, we prefer using a naive Bayes algorithm. Naive Bayes is something that works usually well for text data. But ultimately, you will still try and test it out. Okay. So first thing, you go and use CountVectorizer. You take the text and you try to convert it into a document term matrix. You convert it to a DTM. Okay. You ignore the stop words. You remove the stop words. You convert it to lowercase and you create the DTM. And the second step that you do is you build a multinomial naive Bayes. So that's the way how we work it out. It's a very, very basic, text processing pipeline that we have created. You can see. So the biggest learning from this entire thing, you can see this code is exactly the same as what we discussed. There's nothing different. Although we are discussing NLP and text data, you can see that there is nothing different in the rest of the code. The only new learning, the primary learning that we had over the last 1 hour is how do we take text and how do we represent that text in a vectorized form? Because once we are able to represent our data in a DTM matrix format, now the algorithms will take over. The same approaches will work: training data, testing data, build a model, train accuracy, test accuracy, classification report, confusion matrix, precision recall. All those things will remain exactly the same. Because remember, machines will only look at your data in the form of an array. That's all that machines care about. They will look at the array and that's all they care about, right? That's the way to look at it. Machines will look at the array and that is all that they care about. And once you have your data in that array form, once you have your data in the array form, that's it. That's it. That's all that is needed actually. That's all that machines care about. Machines will look at your data in the array format. And once you have your data in the array format or the DTM or the document term matrix format, once you have your data in that form, now you can absolutely go and you can pretty much use any of your existing classification models. You can use any of your existing regression models, your clustering algorithms, any of those kinds of things you can use going forward. So that's one way to look at it overall. Okay. So you can ignore the rest of the part. Deep learning part we will discuss later. Obviously, we'll come to that conversation. But I hope everyone's clear until here. Everyone's okay. So we are having a pretty decent model. You can see, and you can also see there are two classes, good and bad, and you can see. And obviously, very very obvious that the number of negatives are less, right? So obviously, if you look at my actual data, the support value, support stands for the frequency. That means in my test data, how many number of negative reviews do we have and how many number of positive reviews do we have? And very clearly we can see that the number of negative reviews is comparatively the number of negative reviews is low. So the number of negative reviews is very low, which is expected. The company is a good company, people are happy with the services, so people will not say bad things about the company, right? So the number of negative reviews are on an average low. So there are lesser examples of negative reviews, but there are more examples of positive reviews. That's the inference we are getting, right? So there are lesser examples of negative reviews. There are more examples of positive reviews. So the model that you finally end up building tends to be better in identifying positive reviews. So the positive review scores are higher. You can see there's 95% F1 score, which kind of means that, okay, whatever sentiment analysis model that we have built is better at identifying positive reviews, but it is not that good in identifying negative reviews, which is understandable because one is there is less number of examples, and second is if you look at the negative reviews, it's harder. Negative reviews are harder to detect. There can be sarcasm, there can be a lot of different ways people can People can write a review, and negative reviews can be substantially, harder to, detect. So that's one of the ways to, look at it. Okay, there are a lot of examples of these kinds of, comments that we can look at. A couple of these examples I wanted to share with you. So this was a post. This was something that happened quite some time back. It's not a new thing, but I'm sure some of you would have heard of it already. So this was a post by a person, right? You can see, and I know the text is not perfect, but you can make it out, right? So thank you for sending my baggage to Hyderabad and flying me to Calcutta at the same time. Brilliant service. Die Indigo. This was long back. This is 2017. And if you see, the model responded saying, glad to hear that. So most likely it was a rule-based model. It looked at some of the keywords like brilliant and service, but it did not really understand the context of the word, right? So you can already understand that although it's a negative review, but identifying negative reviews can be very hard. There is sarcasm, there is inherent sarcasm, which the model is unable to catch. So a simple word count based model, a simple count vectorizer model that we talked about all this while, will not be able to solve these kinds of problems. Most likely Indigo was using a count vectorizer model and they were not able to understand the inherent meaning of the sentence. They were just looking at the word brilliant, and the word brilliant came, so okay, glad to hear that. But I mean, so obviously that is not what the person meant. Right, so these are all very real, use cases that I wanted everybody to understand that sarcasm is something that is very hard to, very hard to detect in a real world scenario. Or it can be a more neutral comment. There can be a more neutral comment, right? So I mean, so you can have a more neutral comment as well. Like this is the one that happened some days back, and if you take a look at this, very interesting. So this person actually paid for a window seat. So this person paid for a window seat, and as is the current trend today, everybody wants, everybody will post things on social media, right, for their own set of fame. So here this person goes and says, "I paid for a window seat. Where is the window?" Right. So you can see this is not like a negative comment. This is not like a negative comment, but in the context of the business, this is still negative. So this person actually paid for a window seat, but when they went and when he sat beside those, there's no window. So the window seems to be closed. So I mean, you will see the Indigo plane sometimes like the row is a window row, but you don't have a window. It's like there's this complete an obstacle there. So that's it. So this is the neutral comment, right? If you look at either of the techniques we discussed, like the the count vectorizer approach, there's no negative words a person used, right? Where is the window? So it's not saying good, bad, nothing. There's no feedback the person is sharing. So the count vectorizer model will completely miss it. Okay, the word count based model will completely miss these kinds of instances. Okay, but if you really look at the context, the sarcasm is he's being sarcastic, right? This is a very sarcastic comment. So it's actually a negative feedback because you paid for something, you didn't get it, right? A horrible service, actually. He didn't use those words, but you get the idea why negative reviews are very hard to detect.